Hey, good morning, everyone. I'm audible.
Morning, sir.
Hey, good morning. So today's topic it is going to be polymorphism. So we covered many of the topics as part of inheritances, and we're going to keep on reusing the inheritances, but we will be moving on to further topics. Okay. So in today's session, we're going to discuss about polymorphism, and we also discuss like public, private, and protected variables. So what are the different type of variables also in a class? Okay. So now, uh, so this topic, the polymorphism, is one of the key concept in the object-oriented programming. This thing, what happens is polymorphism means it's just like we take one word, okay? Poly. Poly means it's a many forms. Okay, poly means many forms. The ability of a method changes in a different forms. So that is what we call it as a polymorphism. What is it? The ability of a method. Okay? The ability of a method changes at the many forms. So, for example, I can give you a real-time example. Okay, you take any one person. You take one person. Okay, when he born, what happens? He's a kid. He's a son to his mother and father. Right. Later he grows and he gets another sister. So now he becomes a brother. With the role of the person, earlier he's only son. Now he becomes a what? Brother also. Later, now as he grows by, he gets married. Now he becomes a husband. And later he gets a kid also. Now he becomes a father. The person is same. Okay, the person is same, but his role has been changing, right? The change in the role is called as a polymorphism. This is the most common example everybody take it as a reference. So you can relate it in a real time. Okay, so the same person having a different roles is called it as a polymorphism. Okay, in polymorphism, we have two type of polymorphism. As an object-oriented programming, we have two type of polymorphisms. Among them, one is compile-time polymorphism, and second thing is runtime polymorphism. Okay, but now just let me know whether you understand what is polymorphism. Polymorphism is nothing but many forms. One person has different roles. Like the same way, a method has different roles. That is all a polymorphism is all about. If you understand this line, then I can proceed further. This entire polymorphism is running on that one single line. Can you relate it?
Yes, sir.
Yeah. So once you understand the definition, so we have how many types of polymorphism? The number of types of polymorphism we have only two, which is compile time and another one is the runtime. Okay. So let me give you an example of compile time polymorphism. Compile time polymorphism is nothing but overloading. It can be constructor overloading or it can be method overload. And we have runtime. This is overriding. What is it? Overriding. This is can be same thing, either constructor and either method. This compile time polymorphism overloading concept I already did explain when the time of object creations. Object creations. I explained you how a constructor can be overloaded or method can be overloaded. I'll refresh this concept also, not a problem. And today we mainly focus on these two topics, which is very main. Okay. So let me give you an example of how a compile type polymorphism looks and how a runtime polymorphism looks. Once you understand these two, that is all you have to know as part of this topic. Let me give you an example. I'm having a class called A. Okay. In this class, I'm having a one constructor. I'm having what? Another constructor, one constructor, which is self. This constructor will not take any arguments. Okay, zero arguments. This is what everybody familiar, right? I believe few of people who missed previous classes. I'll explain it with details again. What happens? You have a class, and in the class you are creating a constructor with a init keyword. So this is a normal a class looks like. Now what I'm doing is I'm trying to create another constructor. I'll create another constructor. How you can create another constructor? Using init, right? Init. This time I'm taking self. Now what I'm doing, instead of zero arguments, I'm giving one argument, which is x. This will take one argument. Now what I'm doing is I'll have x as an argument. I'm having the same constructor name, same constructor. The way you are declaring a constructor in Python is going to be same. But here you are having zero arguments and you are having one argument. Now I can say this is overloaded. This is a overloaded because there is a two. If it is more than one, that is what is getting overloaded. Overloaded means there is multiple things. Okay. And let the same thing do with the methods also. I'm having M1 method. In the M1 method, I'm self. I'll take no arguments. Zero arguments. Okay. And now def M1. Now I'm taking one more argument. This is going to be void. Okay. So let me run this class. Class got run. No, there is no syntactical errors. Let me create an object of it. If you see here, I'm trying to create an object of zero parameterized one. I'm trying to create a constructor of zero parameterized one. See here what happens. Okay. See here, what happens. It is expecting one argument. It is expecting one argument. That argument is what? X. I'm trying to create a constructor of zero parameterized one. If it is zero parameterized one, you don't have to pass the argument, right? But Python will not allow it. Python will not allow it because the concept of overloading is not possible in Python. Either that can be method or either that can be constructor. Overloading is not possible. Okay. Every time anything, even though you duplicated it 10 times, it will always take the latest one. It will always take the latest one. What is the latest one? So this is Python will come and say, okay, there is a constructor, that is fine. But what happens? It will come here. There is another constructor with a zero parameter. No, there is one with one argument. So this is going to be our latest one. It will consider the latest one itself. So now it is expecting one argument. You have to pass one argument to create a constructor. Otherwise, you cannot create it. Okay. So now what happens? What you have to do? You have to come and create a constructor of with a one argument. You have to pass one argument. I'm passing one argument, which is 10. If I create now it will get created. See here, I'll have x as an argument. So which one is getting called? This getting called. This will not get called at any time. This is just a duplicated. This is never gonna call. It is just a dead code. Okay. Constructor duplication. duplicates or overloading never possible. Even in the case of methods also. Even in the case of methods also. Now what I'm doing? I'm taking that object reference A dot. I'm giving M1. See here, I'm getting only one M1 method. Though I created two M1 methods, I'm getting how many? Only one. In this M1 method, I'm not passing any arguments. I'll not pass any arguments. See here what happens? It is expecting one argument, which is why. What? Because it will come and see Python, and there is M1 method. Then it will go and check there is another method also with the same name. So now this is going to be our latest one. Now this Python will expect to pass to the one argument because this is the latest one. Always remember that in the times of constructor or method, it will always take the latest one. It will always takes the latest one. So that is the reason constructor overloading or method overloading is not possible in Python. If anybody asks you, no, constructor overloading is not possible. Okay. Any doubts in this? This is a very simple topic. Sir, in this case, there is another approach to can solve this problem. What that problem is, you have to change the order. Let me change the order. I'm changing the order now. Now first I'm giving 0, 1 argument 1. Now later I'm giving 0 argument. Same thing I'll do with the methods also. Sir, as you told me, it will always take the latest one. Correct? So now I change the order. Now let me create an object of it. Let me re-execute this class. This class A is equal to A colon. Okay, so I'm creating a constructor of A parenthesis. This time I'm trying to create an object of first argument. I'm passing one argument. Now it will come and say, idiot, you are trying to pass one argument, but I'm not expecting one, no, more than one. You are giving me two. Definitely I'll give you five because Python always takes the latest one, correct? If you do this, you get error. See here, it is expecting only one, but you have given two, right? The same thing goes with the methods also. Okay, without object creation, it's not valid. I'm giving the 0 and this is fine. Making sense? Because it will take the latest one. What is the latest one? This is 0 arguments one. This is the latest one. Now go to M1 method. On this constructor, I'm calling that M1 method. If I'm giving the 0 arguments one, this is fine because 0 arguments one is the latest one. Correct? M1 0 arguments. But if you are trying to create a M1 of old one, this is the latest one. This becomes a old, right? As soon as there is a latest one. Now I'm going to create a method of some arguments one. I'm creating 20. It will give fail. Okay, because it is expecting only one argument, but you have given two. So compile time polymorphism fails here. You always remember compile time polymorphism is not possible in Python. The question is same. Is it like overloading possible? No. Is compile time polymorphism possible? No. Both are same. Is compile time polymorphism is nothing but a overloading. Getting it? Clear?
Yes.
Yeah. So next topic, I will be moving on to runtime polymorphism. Okay. The runtime polymorphism is nothing but the change in behavior of a method at the runtime. Okay, so that's what I told you, right? It's the change in behavior of a method at the runtime. So the compile time polymorphism is changing it because the compile time itself you are defining it. Runtime means at the time of program execution. The time of program execution. the time of program execution. So the method behavior will change. The method behavior will change. So that is what we call it as runtime polymorphism. Let me show you a demo. Okay, what I'm doing is there is always remember that there is one rule. Runtime polymorphism works. Runtime polymorphism works only in the case of inheritance. If there is no inheritance, there is no runtime polymorphism. This one, understand it. That's what I told you in the beginning. We're going to keep on uses the previously covered topics. Okay. Runtime polymorphism is only possible only in the case of inheritance. If there is no inheritance, there is no runtime polymorphism. Getting it? Okay. Let me show you what I mean. I'm creating a class A. In this class A, I have one method, M1 method. Okay. This M1 method is having self. Print of A class M1 method. Class B. Therefore, M1. Just I'm doing just pass. Just doing pass. Now what I'm doing, let me execute this, create an object of it. Now, if I try to access A class M1 from a B class constructor, what I can do? What I have to do? I created a B class constructor. Okay, but I want to access A class M1 method. How I can do that? From a B class, I want to call A1, A class M1. How that can be done? Hmm? Okay, for example, I'm giving B dot under the space bar. This M1 is coming. No. Then what I can do? What I have to do to in order to able to access it? I have to do inheritance. Just access a class. Let's re-execute this one. Now B object reinitialize it. Now put B dot under the space bar. Now M1 method is coming. Earlier it is not coming because there is no inheritance. There is no relationship between them. If you want to access it from B class, A class M1 method, then you need a relationship. If you're not having a father and son relationship, do you go and claim it? You are not his son. You are going to ask his property. You think he will give you? He will kick you out of the door. It's like B dot M1 method. Now you can access it. This is what a normal inheritance works like. That is what I have been teaching you. I don't know whether you guys are practicing it or not. Okay. So this is what inheritance, right? Now what I'm doing. Same thing I copy pasted here. A class and B class. In the B class also, I'm going to create the same method. Same method. Okay. Instead of simply passing, I'm creating B class. Now this is B class M1 method. Now what I'm doing? B class M1 method. Just execute again. Let me create an object of it. B is equal to B of constructor. Now I put B dot interval plus space bar. I'll get only one M1 method. I'm getting only one M1 method again. If I call this, what happens? What gets executed? What will be the output?
A class method.
Hmm?
A class method.
Yeah, very good. Getting it? So if you see in the above example, Python will go and check whether M1 method is there in the A class or not. So B class. So since you are calling in the B class constructor, right? B class object reference. First, it will go and check whether M1 method is there in the B class or not. If it is not there, then go and look for the A class. So that is the reason you are getting A class M1 method. In this case, what I'm doing is this is nothing but overriding. This M1 method is overridden from A class because the signature is same. The method declaration is same. What happens is first Python, whenever you are calling that M1 method on B class object reference, first it will go and call, see whether M1 method is there. Yes, it is there, it will check it. Here, I have my own implementation. Okay, then it will print the B class M1 method only. Only B class M1 method is called. This is nothing but overriding. Here, this concept is nothing but what is called overriding. The rule should be method name should be the same. And also number of arguments should be the same. If you see here, I'm having 0 arguments, and this is also 0 arguments. That is the reason I'm saying this is an overridden method. Sir, now this is good. Now this is good. What happens? Not only I want this M1 method to be called, I want to call the A class M1 method also. My question is clear. From B class object reference, I want to use the same B class object reference. Not only B class M1 method, I want to execute A class M1 method also. Is it possible? Yes, it is possible. There is a different functionality there. Let me show you that. Let's take this entire class. Copy paste it. As your object, what is your requirement? From B class constructor. From B class itself, you want to execute A class M1 method. Then what you have to do is, you have to do super. You have to use a keyword called super. Super is always referring to the super class. This is what a super class, right? A is what? Super class. When there is an inheritance, A is a super class. Now this is a subclass, right? When you are using a super function, you are referring to super class values. And this super, I'm going to call M1 method. The super from, go and check the super class, which is a super class is what? A class, right? Go and check the super class. Is there any M1 method? Execute that also. I'm using super method, okay? Super function. What happens is Python will go, okay, is there any super class? Yes, there is inheritance. I'll go and call the A. If there is any method name M1, let me execute that. So that's what it happens. Let me execute this. I have executed that. Now I'm creating an object of B class again. This B class object, I'm putting control plus B dot M1 method. If I execute this now, see here what happens. If I execute this, you are getting A class M1 method also executed. So that is the reason only you are getting this output, right? You are getting A class M1 method also called and B class M1 method also called. Both the things you are calling. Because if this line is there, so that is the reason your A class M1 method is getting executed. I just commented out that and I'm re-executing this. See here what happens. It will print only B class M1 method. Only this line is calling the super class M1 method. So let me uncomment that. Now what I'm doing, instead of here, I want to keep it in the next line, in the second line. Can I do this? It can be anywhere in your method. You can call it at any point of time. It should be an instance method. That's it. If I execute this, let me re-execute this. If I execute this, now what happens? It will come and check the M1 method. It will print first B class M1 method. Then later it will go and print the A class M1 method. So now output will be B class M1 method, then A class M1 method. Observe. Earlier it is A class M1 method, B class M1 method. Since I change the position, automatically the printing statement also changes. Here, sir, up to method level, this is fine. Then how about the constructors? So it should be part of both method and constructor, right? That's what I told you. Again, it can be constructor and method, right? Method is fine. Then how about a constructor? Then how about a constructor? This is a class, f of init. What happened? I just created a class and B class. There is no relationship between these two, and I'm executing it. This is simply works. Okay, I'll keep on improve this. I'll keep on improve. This is a constructor one now. I established a relationship now. Established a relationship. See here. As soon as there is a relationship, and I don't have a B class constructor, I don't have B class constructor. It is just a simply pass statement. The first thing what it is doing, it will also goes and execute A class constructor. It is called executing A class constructor also. If I don't have any constructor, if I don't have any constructor in my B class, it will go and call A class constructor, and A class constructor is getting printed. I don't have any print statement in my B class, right? Now it is going and printing A class constructor. Let me improve this. What I'm doing is, earlier I don't have any constructor in my B class, correct? Now I'm having my own constructor in the B class. I changed the constructor now. So now I'm doing. So now earlier, if there is a no constructor in the B class, it is going and printing the A class also, right? It is going and executing A class constructor also. Now I have instance, no inheritance relationship. Though I have inheritance relationship, see here what happens. So I have inheritance relationship, it will just call only B class constructor. Because the time, if you don't have any constructor in it, Python will give you that constructor, correct? If Python is giving you the constructor, it will go and call the superclass constructor also. Remember that. When Python is giving if Python is giving the constructor, it will call the superclass constructor. So you will call the superclass constructor also. Fine. Now what I'm doing is I have A class constructor and B class constructor. Now what I'm doing is B is equal to B of parenthesis B constructor. What is happening? It is will be executing only B class constructor. Not now. Earlier I have given you example, right? Not only B class M1 method. If you want to call A class M1 method also, what you have to do? Super. What you have to do? Super, right? The same thing you have to do it here. If not only B class constructor, you want to execute what? A class constructor also. A class constructor also. Then change your method like this. Or superclass constructor. Then you have to use what? I told you, right? When there is a method, what keyword you use? What function? Super function. The super function, what you want to execute? Init, right? Init is the constructor. Init is the constructor, right? Let's re-execute this. Now I'm creating an object of B class now. I'm not creating A class objects. See here what happens. What it is printing? It is earlier, it printed only A class constructor, right? So B class constructor. When I was doing this, B is equal to B object creation. It is executing only B class constructor. Now, as soon as I added this line, not only it is executing the B class constructor, it is going and executing the superclass constructor, which is the superclass A class. Now I have an inheritance, right? Since there is an inheritance, it will go and execute what? Superclass constructor also. You are using a function called super. And which function you want to call it? Which constructor? You're gonna call that in it. This is all you have to do. Now you understand, right? If you know not only the constructor overriding, you can do method overriding also. But if you want to call superclass constructor superclass method also, you have to use super. For example, let me give you the entire demo in a single class. Let's take this entire things. Just paste it here. Let's take the M1 methods. Now, if you see here, what is there? Now there is a relationship between these two because there is an inheritance, correct? Now I'm having my constructor. Once there is a relationship between these two classes, you can call a superclass constructor also from your subclass. Now B is what? This is a summary of entire discussion, right? B is subclass.
Yes.
A is what? A becomes what?
Hmm.
Superclass. Making sense? Now what I'm doing? I'm overriding that M1 method. Now overriding is I'm doing overriding. Now what I'm doing, not only B class constructor to be initialized, I want to initialize the A class constructor also. That is what this line is meant for. It can be in anywhere. It can be anywhere in your constructor. Not only the first line, it can be second line. In Java, the calling a superclass constructor should be the first executable statement. So that is the reason it can be anywhere. It can be anywhere in the Python. You just have to simply call that. Not only first or second, even you can change this position, calling that superclass methods or constructors. Let me execute this. No errors, no syntactical errors. I'm creating a B class object now. As soon as B class object get initialized, first it will go and call what? Init method, init constructor. What is the first statement? B class constructor. Okay, let me print the B class constructor. Then what you are doing? You are calling the superclass constructor. What you are doing? This line is meant for calling the superclass constructor. What is the superclass here? Go to the A class. A class constructor is there. Go and execute the A class constructor, which will print A class constructor. First B class, then A class. See here, first B class, then A class. Getting it? On B class now, on B class, and I'm calling M1 method. I'm calling the M1 method. If I execute this, what happens? First, it will go and check B class M1 method. Okay, this there, it will print it. Now, what you are doing? Calling the superclass M1 method. You can change this order anywhere. You can change this. So this. Yes. So here, it's A class M1 method and B class M1. Here, now what I'm doing is, I'm doing def of M2. I'm creating another method, self. This is what? M2 method of B class. Now what I'm doing is, I'm calling the superclass, the superclass A class, right? Superclass is what? A class. In this A class, I'm calling that M1 method. Go and check the superclass. In the superclass, there is a method called M1 method. Getting it? Let's take this entire thing. Will not change this behavior. Let's keep it that there. Let me create this entire new things. What I'm doing, I'm having M2. Earlier, what I'm doing, M1 class, M1 method, I'm calling the M1 method only. Super class M1 method, that is fine. And I'm having M2 method. In my M2 method, I'm calling what? A class M1 method. Calling A class M1 from M2. Let's initialize. Now P is equal to P. It doesn't have any arguments. First go on print B class constructor, then A class will get executed. Fine. Then what I'm doing on B class, I'm calling M2 method, not I'm calling M1 method. I'm not calling M1 method. Okay. You want me to remove? I can remove that also. I'll show you that. For now, just understand B dot M2. I'm calling only M2 method. What it should print? First go and execute M2 and method of B class. M2 method of B class. M2 method of B class is printed. Later, what you are doing? You are calling the super class. You are saying super, right? Super function. Go and check the super class. In the super class, there is a method called M1, right? Go and execute that method. That is what you are saying here. Go and call if there is a class called super A, which is A class. There is a method M1. Go and execute it. I'm calling not M1. I'm calling from M2. Okay, understand the differences. This is very, minute points you have to remember. Here,
Yes, sir.
yeah. So there is one more alternative. This is the last topic for today. There is another alternative to call it a superclass constructors. There is another alternative to call a superclass constructor. That are the alternative is another approach to call the constructor class right? Then next step is P is equal to B constructor. Only I'll get output B class constructor. Right? Then if you want to call what super class constructor, you have to use super and double in it. Do this, then you are initializing the super class constructor also. There is another alternative. There is another alternative. You don't have to use this super. There are that other alternative is use a class name. Which class you are you want to create? A class, right? A class. In this A class, call the super class constructor. That constructor. In the A class, there is a constructor is there in it. Call that. This one take one argument. That argument is self. We are passing B class self keyword to there. And execute this. See here. There is no change in behavior. It will work exactly same. This got introduced because multiple inheritance is possible in Python. Because you are at the same time you are having multiple classes, right? Which class constructor you want to call? There is a problem of ambiguity, right? In multiple inheritances, there is a mother and father, right? Remember? In multiple inheritance, let me take that example. This property, right? Okay, so here instead of methods, let's take the constructors. F of don't know all these things. I think make sure it is in the right integration. This is fine. Multiple inheritance is possible. Now what I'm doing? Some class object, right? Now what I'm doing is I'm calling super, like the earlier case, calling superclass constructor using a super now. Okay. Now let's reinitialize this. See here what happens. You're going and calling what? Father class constructor, because I told you that as part of yesterday's session, we have a concept of MRO, method resolution order, even that is there. Okay. Because since you are doing first father inheritance, it will go and call the father class inheritances. Now what I'm doing is I'm not going to use the father super. If I use the super, only father class constructor got a call. Now I don't want not only son with the father, I want with the mother also. Then what you have to do, just use father, double underscore in it, and use self. Now what you are, let's execute this. And execute this. Any change in output? No. You are just changing the code. That's it. Calling the constructor, they are just changing it. Now I'm calling the mother one also. What I'm doing, I'm initializing the mother class constructor also. Understand? This kind of code was introduced because in this case, in terms of multiple interfaces, multiple inheritances, to resolve that error. Otherwise, this super is enough for us. If there is a single level or multi-level, but there is a multiple inheritances there, right? Since there is a multiple classes, a single class is inheriting both the classes. In these cases, this concept is introduced. So with this, the problem of multiple inheritance is resolved. Okay, so this is all. Just polymorphism is all about calling the superclass constructors, calling the superclass methods. So that is all polymorphism is all about. What is polymorphism? Polymorphism is many forms. The ability of a methods or constructor or changes at the runtime. The ability of a method changes at the runtime. That is what a constructor is all about. Then how you can, how many types of polymorphism? We have two types of polymorphism: compile time polymorphism, runtime polymorphism. Compile time polymorphism is what? Overloading. And runtime polymorphism, overriding. Overloading is not possible in Python because Python will always take the latest one. Either that can be a constructor, either that can be a method. It will always take the latest one. Since it is ignoring the old one, so overloading is not possible. But in Java, it is possible. You can compare with other programming language. In Java, it is possible. Okay. In runtime polymorphism, it is possible in Python. But runtime polymorphism to be applicable, there is a rule. There should be inheritance. If there is no inheritance, you cannot achieve overriding. Okay, once you've done inheritance, if you want to call the superclass constructors and superclass methods, there is a key function super. Use a super, you can call it. From one function to another function, also call it. Clear? Okay. So let me give you another example. Okay, this is the last example I want to give you. What I'm doing. Okay. Now what I'm doing is I'm not going to call it from a constructor. I'm not calling from a constructor. What I'm doing, I created a method. This method is test method. This is having a self. This is having what? Self. In test method. Print of what? Test method. I executed that. Now sun is equal to sun. Okay, it is going on calling what? Father class constructor. This is expected behavior. Now what I'm doing? On this sun, I'm calling test method, test underscore method. Printing. Fine. Now for the same thing, I'll change one slide behavior. What I'm doing is not only the print statement, I'm calling the father class constructor now. So you can call the father class constructor uh, without super function, use self this way, right? Now what I'm doing method. Not from the constructor, I'm calling from a method. Okay. Can do this. Now, if I create an object of it, it will go and call the father class. It will go and call father class. The output will be father class. Okay. But on this sun class, sun object reference, I'm calling what? Test method. As soon as you call the test method, okay, since you call the test method, okay, let me call the test method. What is the first statement? Test method is there. I'll print the test method. What you are doing? You are calling the superclass constructor, which is father class constructor initialization you are doing. Okay, see here what happens. Exactly see what happens. Understand? This is a test method. This is the first statement. I'll print it. Now what you are doing? You are using father class initialization. I'll call the father class constructor again. And I'm calling the mother class constructor. That I'm calling the mother class constructor. Understand it? Not only from a constructor, we can also call these from instance methods also. From instance methods also, we can call the superclass constructors. This is all you should know as part of polymorphism. That is all for today. Simple. Please practice this yesterday's and today's session. Okay, so then you will understand more and more when I explain about encapsulation and abstraction. For now, we discussed inheritance and polymorphism. There is only 2 topics pending as part of groups. Then we'll move on to the further topics, which is exception handling, file handling. Please practice today's and yesterday's classes. Any doubts so far?
No, sir.
Yeah, that is all for